All right, welcome to section 2.4, crazy clocks and checking out bars. This video has a lot of computational math, so please pause often, do the problems, rewatch them, and attempt them on your own. So start here. Question of the day, suppose your watch says 9 p.m. You're having the biggest meeting of your life in 37 hours. What's the quickest way to determine what time that meeting is? Go ahead and pause here. Figure out the answer, see if you could have done it in a quicker way, and we'll circle back to this one later. So now we're going to talk about mod clock arithmetic. So we have regular clocks, have 12 at the top, right? They don't have the 0. What time is 19 military time? So we would go around the clock, once would be 12, and then we'd say, okay, how many are left over? 19 minus 12. We have to go 7, so that would be 7 o'clock, 7 p.m. So 19 is equivalent to 7. What about 21? So same thing, we're going to go around once. We get, so 21 minus 12, what's left over? We get 9. That's how much we go around. We get 9 p.m. So 21 is equivalent to 9, which is kind of nuts. And 21 is equivalent to 9. 19 is equivalent to 7, but we're comfortable with that, right? Well, what if we change the clock a little bit? So this time we start with a 1 at the top. What time is 12? Okay, so let's see here, 12. If we go around, that would be 7. That's actually 8. 9, 10, 11, 12. 9, 10, 11, 12. 12 is 5. How does that feel? Maybe a little bit weird. Go ahead and try that one again. What about this clock? This clock has 0 on it. What time is 15? So if we go around once, 0, 8, that's 9, 10, 11, 12, 13, 14, 15. We get 6. 15 is equivalent to 6. And now we're going to be looking at kind of these clocks with 0. If 15 was equivalent to 6, well, we could say that the remainder, the leftover, 15 minus 9, the remainder, the leftover was 6. And that's what we're going to be doing with modular arithmetic. We're going to get rid of the clocks, and we're just going to look at the remainder. So we'll keep the clock here and make sense of this. So on this clock, what is 9 equivalent to? 9 is equivalent to, let's go around the clock here, 9 is equivalent to 0, right? That's 9, 8, 9. What about 10? Well, 10 is equivalent to 1. 15, we did this, 11, 12, 13, 14, 15 is equivalent to 6. What about 18? What if I don't want to go around a little bit more? I can, 16, 17, 18, but I could also see, well, 9 is equivalent to 0, so 18 is also going to be equivalent to 0. Those are multiples of each other. What about 24? Well, if this is 18, what about 24? Well, okay, 20, 18, 19, 20, 21, 22, 23, 24 is 16. Okay, so we're dealing with the 9s here. Is there another way? Okay, that wasn't too hard, but 37, I don't feel like counting it. How many times do I have to go around? So let's see here. If I look at 37, so I would go around 9 would be 0, 18 would be 0, 27 would be 0, 36 would be 0. Okay, that's how many times I would have to go around to get to 36. And so 37 would be 1, 36 plus 1. So it's equivalent to 1. 37 is equivalent to 1. 84, I'm certainly not going to run all the way around. What is the biggest multiple of 9 that goes into 84? So let's see here. 1836, well, 9 squared is 81, right? So it would be 81 plus 3, because this would be 0. 81 plus 3, so this would be equivalent to 3. Okay, so we can actually use a different language here to say that 9, and I'm going to add another equal sign, is equivalent to 0 mod, what's my mod here? 9. and 10 is equivalent to 1 mod 9, and 15 is equivalent to 6 mod 9, and 18 is equivalent to 0 mod 9 because it's a multiple of 9, right? This is 9 plus 1. This is 9 plus 6. 24 is equivalent to, ooh, I said 16. I should have said 6. 6 mod 9. Well, let's think about that. Well, 9 plus 6 is 15. What about 9 times 2 is 18? 18 plus 6 is 24. 37 is equivalent to 1 mod 9 because 9 times 4 is 36, and then add 1. And then 84 is equivalent to 3 mod 9. Let's look at another clock here. So, excuse me, that's the same clock, so I just was giving myself a little more space here. So the idea here is that these are all the remainders. Now, they're not all remainders for 9, but for multiples of 9, 9, 18, whatever. And if we were to change the mod, we could actually still do this. It doesn't have to be mod 9. Let's look at this clock. This is a new clock. All right, so first I'm going to see, well, what's my mod here? What's going on? It's not 7. If I were to go around, what's equivalent to 0? That's my mod. If I go around, that's 8. All of these are mod 8. That is what's equivalent to 0. Okay? That's what we're multiplying or dividing by, no matter how you think about it. So 9. Well, maybe I don't want to use the clock here. Let me just see here. 8. If I was to go around 8, what's my remainder? What's my leftover? 1. What's my leftover after 8 to get to 10? 2. Now, 85, I don't want to think about running around, but 85, if I eat 80 is equivalent to 0, right? These are all the same thing when I go around 80, so this would be 5 because it's the leftover. Remember, mod 8, you know, these are all the same. 16, you know, 24, and then 8 times 8 is 64, 72, and then 80, and you're looking for your highest multiple of the mod, and then your remainder. So see if you can actually do these ones first if you want on your own, but I'm going to do them with you. Is 27 equivalent to 1 mod 5? All right, so mod 5. All right, so we're talking about multiples of 5. So what are the multiples of 5? So we've got 5, 10. What's the biggest one close to 27? I don't want to do them all. 25. 25 plus what gives me 27? Plus 2. So this is not true. 27 is actually equivalent to 2 mod 5 because that's the remainder. All right, 157 is equivalent to what mod 3? Well, I'm certainly not going to list out my multiples here. So I'm actually going to do something a little different. I'm going to use my calculator. What is 157 divided by 3? I just want to get my biggest number. I know it's a decimal. 52. Okay, what's 52 times 3? 156. That is going to get me close. 156 is really, really close to 157. What's the remainder to get to 57? 1. Okay, how about this? Mod 10. All right, what's the biggest multiple of 10? That gets me close to 62. It's 60 plus 2. So why is blank mod 8 blank equivalent to 8 mod 6 not possible? Well, the reason why is mod 6, all of these numbers have to be on the clock between 0 and 5. Let's look back at our clocks here. When we were talking about mod 8, we only went up to 7. When we were talking about mod 9, we only went up to 8. Because as soon as we get to mod 8, 8 mod 6, what's 8 equivalent to mod 6? What's the leftover there? That's equivalent to 2, 6 plus 2. So we wouldn't have 8, this would be 2. So go ahead and give these 3 a try. Press play when you're ready to see the solution. And then let's answer that question. Suppose your watch says 9 p.m. You're having the biggest meeting of your life in 37 hours. All right, so we want 9 p.m. plus 37 hours. Well, let's not do 37 hours. Let's say 24 hours because we're comfortable with 24 hours, right? All right, so 24 hours, that's going to be at 9 p.m. right? So 9 p.m. at 24 hours, it's going to be 9 p.m. the next day. And how many hours are left over? 13 hours. Well, let's not think 13 hours. Let's think 12 hours, because that is, we can say that that would be equal to 9 a.m. And then what's left over? Plus 1 hour. Your meeting is at 10 a.m. So we're going to pause here, and when we come back, we're going to see where modular arithmetic actually exists in the real world besides clocks.